guys, it's RJ. We're going to talk about freshwater generator today. Before we start, how do we get water during sailing? Do we need water? Of course. And what kind of water do we need during sailing? And how do you make them? Well, first we need drinking water, right? Everyone needs to drink during working, during living, anytime. Drinking water, of course, and fresh water for our ship system, and also taking a good shower after working. So first we'll talk about the principle of freshwater generator. The principle of freshwater generator is to use the heat from main engine jacket cooling water to produce drinkable water by evaporating seawater due to the high vacuum, which enables the feed water to evaporate at a comparatively low temperature. Hey, what are you talking about? What does it mean? Well, simply it means you have to boil the water at a temperature of about 85 degrees Celsius and condense the water into fresh water. Quite simple, right? So we'll talk about the most commonly used freshwater generator, which will be shell type. This is a shell type. This is me, really furious about the freshwater generator. And this is the tube type. So we're going to talk about two types, shell type and a tube type. The principle is actually the same. And we'll talk about the tube type first. Okay, before we start, I will mark the hot water in red, which will be jacket cooling fresh water, and seawater in green, and fresh water in blue. So we'll talk about the jacket cooling fresh water first. The hot water. What is the hot water? It's the jacket cooling fresh water from the main engine. So the hot water enters here, and in this picture, the arrow points as if it's going like this, right? But actually no, it will go more like this. In this picture, it's not like written, it's not here, but there's something called a baffle plate that's installed like this. So it will have more efficient heat exchange. So we'll go pass through these tubes more often, a lot. So this is it. The jacket cooling fresh water, this is it. That's all. I will erase the baffle. Oh no. Okay. One more time. The hot water will go pew, 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 pew. It'll go out like this. Okay. And then the seawater. First, the water comes in, it passes the ejector pump, it passes the ejector, and then it fills up this place. And after it's filled up, it will go pass through these tubes. And it will fill up this space. And most of the water will go outside and go overboard. But some of the water will go here and fill up this place. And it will go back by using this tube on the top and fill up this place, and it'll go whoop, like this way. It says feed water, right? So we're going to use this water to feed the freshwater generator and make it evaporate and make the fresh water. And as it passes, and as the feed water accumulates down here, it will soon go up through these tubes. Do you guys get why this is called the tube type? See, as the seawater passes through this part, it says heater down here, right? The jacket cooling fresh water is exchanging heat with the seawater, which will make this seawater boil. The jacket cooling fresh water is around 85 degrees. But how does it boil? RJ, the water boils in 100 degrees Celsius. But how come you're saying it's boiling at 85? It's evaporating at 85. That's because we're getting rid of the air inside. If we have a vacuum, we can boil the water in a comparatively low temperature. So what happens is there's a line separately here that's connected to the ejector. The ejector will make the vacuum by sucking all the air inside the shell. And this place will be now vacuumed, and which will make us allow to boil the seawater in a comparatively low temperature. It's going to be about like 43 degrees or something. It depends on the ship. So again, the seawater is filled up by the feed water, and it will go pass through the heater, and it will start to boil, and it will start to evaporate. There's something called deflector here. It looks like an umbrella. I'll show you later. Like this. After the seawater starts to evaporate, it will go past through the deflector, and it will go past through the mesh separator. The deflector will make the vapor to flow in a certain path to make sure it passes the demister, which is also the same name as mesh separator. A mesh separator is made out of copper and thin wires, which blocks the droplets going to the condenser side. I said demister, right? Demister, which basically means it's getting rid of any mist that's trying to go up. And after the vapor reaches the condenser, it will start to condense. This pen is really hard. Okay. So after it starts evaporating, it will go past the mesh separator, and it will reach the condenser side, right? Remember, the seawater was passing through here, these two, and the vapor is really hot, and this vapor will meet these seawater, which will be around like 30 degrees. Well, it depends on the sea temperature, but let's say it's 30. And the vapor is really hot, right? It will start to condense. And down here, if you see, it's going to look like some kind of bucket. Like this. And then the distilled water will start to accumulate here. And then you see this line? This is where we pump out the distillate water. And then it will send the distilled water to the freshwater tanks. Okay, let's go over one more time. Seawater. It starts here, it passes the ejector pump, it passes the water ejector, and it will fill up this place. It will pass through the tubes. Some of them will go overboard, and some will come back to the feed line. And it says preheater, right? Why is it called preheater on this side? It's because, you know, the vapor meets the seawater at this place. As the vapor meets at this place, this seawater is preheated a little bit. That's why it's called preheater on this side. Okay? And the feed water starts accumulating here, and then it goes up, passes the heater, which has hot water inside here. And then as it passes, it will start to boil and evaporate. And as it's evaporating, it will meet the deflector, and it will go into a certain path to meet the mesh separator. And after all the droplets are removed, it will go up to the condenser side, and the vapor will be condensed. And after it's gathered, it will be pumped out by distillate pump, and it will be sent to freshwater tanks. Simple, right? This is a baffle plate, which blocks jacket cooling freshwater to escape straightly like this. It will have to go around. It's making the heat exchange more efficiently. Okay? And here, like I said, air outlet to water ejector. There's a line here that's connected to the ejector. Like this. Okay? So the air will flow inside the ejector, and it will go out overboard. And number 3, do you guys see number 3? This is the deflector. It's just an umbrella. It's just a metal thing that's that's like this, like an umbrella. And then the vapor, you know, when the water starts boiling, the water droplets starts like sprinkle like everywhere. This is why the deflector exists. The droplets will not go out, like will start jumping, but it will not go up to the condenser side. And that's the deflector. And here is going to be the mesh separator. And yeah, here, see, this place is separated. So the seawater will be cooling seawater inlet will be first here, and then it will pass the tubes, be filled up here. But there's a hole. There's, see if you can see. See, the seawater can pass through this part. And the feed water is preheated, and then it goes to down here, feed inlet. Then it will pass through here. Whoop, 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 whoop. See? Simple, right? Okay. Yeah, I wanted to talk about water ejector. It looks like this. So the important thing is it's using Bernoulli's principle. So the driving water, which is the seawater, passes here, and while it passes, the pressure drops here. And the air inlet, the air line, remember, comes down here. And the brine comes down here. And they're mixed here. And the mixture out, it's basically just going past through the ejector. This is the brine line. So what's a brine? After the seawater evaporates, the seawater is basically made out of salt and water, right? And some multiple mixtures. After the vapor disappears, there's going to be lots of salts. We call that a concentrated water, which is salt water. We call that brine, and it's accumulated down here. And we don't want this to like build up here, right? So we're just using the Bernoulli's principle. We're using just forget about it. We're using the ejector to eject all the brine out. That's it. This is how the ejector looks like. See, the primary fluid here, which will be the seawater, will come inside and pass through the nozzle. And as it passes through the nozzle, the pressure decreases and the velocity increases. The suction fluid will be brine. It's not shown here, but the brine and air will come at each side. And it's mixed with seawater and is thrown overboard. Due to the suction of the air, it will create the vacuum inside the shell into the system, and also the leftover from evaporation, which is brine, will go overboard. And and it's the one who built the freshwater generator is a genius. I'm not sure who made it, but yeah, he's smart as. Okay. Okay. So this is how the shell type looks like. Okay. The principle, it's all the same. It's the same. See, but it has some different features. There's an ejector down here. So start from jacket cooling freshwater. So it goes in, and it goes out. Simple. That's it. Okay. Seawater. From overboard. Oh, wait. Sorry. Seawater. From sea chest, we use the ejector pump to suck it in. Goes in. La 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 la, la 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 la. But see, it goes on the top side first, which is the condenser side. But we'll go to this part again. Let's just leave it like this. And then it will go this way. And as you can see, it will. Ah, this sucks. Ah! Okay. Okay. Jacket cooling fresh water. That's simple, right? Okay. Seawater. This one. This is the seawater, right? Seawater inlet. It passes here, goes inside the condenser side, it comes out, and it goes down. See, there's a dot here, which means there's going to be another line here that goes over here, that goes down over here. This line will be the feeding line. Feeding. This line will go to the ejector side, which will go out to overboard. Like I said, there's two lines, right? This line will be the brine line, which is connected with the shell. You see this? This is the brine. We're going to get rid of this by using the ejector. So the brine goes down here, and you see this tube. Number 8 is side glass. This one. This is where the air comes in, and it's sucked out with brine and seawater. So basically seawater, brine, and air is sucked out all together. And because the air is all sucked out, this shell will be vacuumed. Okay, let's get that. Okay. And the feeding line, when it's going in here, right? And then notice it just becomes dot, 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 right? Evaporating, because you saw jacket cooling freshwater inlet, the hot water like this, right? So the seawater starts boiling and it starts evaporating. It starts becoming vapor, and it's full of vapor here. And then it will whoop, go down like this, go up like this. Number 18, which is the demister, it's the same, right? It passes the demister, it gets rid of all the mist, and it gets rid of all the droplets, and the pure vapors go up here, and the brine is accumulated down here. And after the vapor is collected here, it will go pass through here, right? And this is the line where the seawater was going in. These are the plates that we're going to talk about. The different feature about shell type and tube type. So, after the vapor passes the demister, it will go to this plate side, which will exchange heat with the seawater that was passing, and it will be condensed. And after it's condensed, the distillate pump will send the fresh water to the freshwater tanks. This is the distillate pump. Okay, so the principle is the same, but we will talk about the plates. As you can see, this is inside the shell type freshwater generator. This is where the brine is going out to the ejector. And this is how the plates look like. And these plates are in order. So you have to make sure you mark them to make sure you put it back in order. The most important plate is the first, and well, of course all the plates are important, but there's four types of plates. See, this is the manual. It says first plate, second plate, third plate, and last plate. So there's only one first plate and one last plate, but between them there's like 37 pieces of second and third plates that's piled up repeatedly. So it goes first plate, second plate, third plate, second plate, third plate, blah, 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 and then second plate, third plate, and last plate. And these orders should not be mixed, because if it's mixed, see, it has a different groove. You see them? This groove, the last plate, this one, the groove is pointing this way. It's facing this way, right? And the gasket looks like this. This is the last plate, okay? But the third plate, the grooves are looking at this way. And the gasket looks like this. See? It has a different gasket. And here, the second plate, this one, the gasket looks like this. And the grooves are facing this way. And the first plate, the grooves are facing this way. The gasket looks like this. See? different grooves, different gasket, different plates. So you have to make sure these plates are not mixed and put in the same order. So if you go back here, jacket cooling fresh water going up, up, up. That's a bad drawing. One more time. Okay, jacket cooling fresh water is going up, up, up. Then it's going out, right? While the seawater is passing through, the feed water is going here, and it's going past through here. So the plates are going to look like this. Let's say this is the first plate, and this is the last plate. It's going to look like the jacket cooling fresh water is going to pass through here, and here, and here, while the seawater is passing through here, and here, and here. Like this, okay? So the seawater and the jacket cooling fresh water is not mixed up together if you put the plate in the same order that you took out. So if you mix this plate's order, I don't know, I don't want to imagine. Just don't do it. Don't do it. Don't do it, okay? Okay, and I think that's it. Let's see. Oh, okay. One more. If you see this line where the distillated water is going out, you see lots of valves, right? What is this? Number 16, this is a flow meter to check how many waters you're making in a day, per day or per minute. You can just calculate it. And here, number 11, this is called salinometer, which will indicate the salinity inside this water, in the fresh water. Usually the setting is 10 ppm, 10 parts per million. And if the water's salinity exceeds 10 ppm, it will make this, you see this pointy thing, sparky thing? This means this is a solenoid valve, which is controlled by this salinometer controller. This is the sensor. As the water passes this sensor will send a signal to number 11, salinometer. The salinometer will see if it exceeds 10 ppm or not. If it doesn't exceed, it will just go pass through and it will go to the freshwater tanks. But if it exceeds, it will send a signal to the solenoid valve to open, which will make the water flow here. And it will not go here, okay? And it will eventually return the water inside the shell. And that's it. I was really, because I'm getting old, I think, I'm not good at touching these computer screens, so please understand. And if you have any questions, leave it in the comments. If I said something wrong, please leave it in the comments, let me know. And yeah, that's it for today. Thank you guys.